In the previous video we saw that for this system of linear equations the solution is this specific value of x and value of y. What's the meaning of this? Well, actually these two equations define two lines, and this solution gives us some point in the plane, and the point is the intersection point of these two lines. Let's see how we can draw a picture about this. Let's a little bit modify the equations. In the first equation we can solve y. Y is equal to minus 2x plus 3. In the second equation we can shift 5 to the left hand side and y to the right hand side, and we get that y is equal to x minus 5. We want to draw a picture, so let's draw the y-axis and the x-axis and some values in the axis. Like this. And perhaps we can make a table. If x is equal to 0, we get that y is equal to 5. So we can draw the point 0, 5 into the picture. Then in our table, if x is equal to 1, y is equal to minus 2 plus 5, that is 3. So we can put the point 1, 3 to our picture. And we can draw the first line through these points. Somehow like this it goes. Let's then draw another line. It has the constant term minus 5 there in the equation, so we will see that if we substitute x to be equal to 0, then we would get that y is equal to minus 5. So because of this, the line will go through this point 0, minus 5. We see that the factor in front of x is 1, so if x increases by 1, y would increase by 1 also. So also this point 1 minus 4 is in the line, and if we would increase x by 5, y would be 0. So also this point is in the line. The second line goes through these points. We have drawn the picture by hand. We didn't have any ruler even. Maybe there are some mistakes, but from here we could estimate that the solution, which is the intersection point, it should be about x is between 3 and 4, so perhaps x is 3.5, and y is there almost in the same level as -2, so perhaps y is -2. This would be the approximation what we get from the picture. If we would take the intersection point what we calculate precisely, and we would calculate the approximate values, then 8 divided by 3 is 6 plus 2 divided by 3, and 7 divided by 3 is 6 plus 1 divided by 3. Plugging these to the calculator would give 2.33 and 6, and y would be, how is it? A little bit less than minus, a little bit more than minus, less than -2, -2.33. Well, okay, our picture is not very good, but the values are corresponding in some way. So now we know that the solution of a system of two linear equations is the intersection point of two lines. So what things can happen? We can have that the lines have intersection point. In that case, the system has exactly one solution. It can also happen that the lines are parallel. In that case, they never meet and there are no solutions. It can also happen that the equations in the system are the same, so they correspond to the same line in the plane, and in that case there are infinitely many solutions. What kind of examples we could have of these two cases? Well, for example, if the equations would be these, then we can see that if we multiply the first equation by 2, we would get the equation 4x plus 6y is equal to 12. And this is contradicting the second equation, because 4x plus 6y is equal to some different amount. We get from here that 12 is equal to 100. So in this case the two equations would be parallel and not intersecting anywhere. On the other hand, if we had the system of equations then in this case, by multiplying the first equation with 2, we would get the second equation. So actually the equations mean the same thing. we can delete one of the equations and we see that all the points in this line are solutions. So in the end we could write the answers for these systems. In the first case there are no solutions. In the second case we can tell that the equations are the same. Oops. So all points x, y satisfying 2x plus 3y is 6 are solutions.